Hello, this is Philip Hebler. This is a record of a solar charging system on a 2016 Nissan Leaf consisting of four 150-watt flexible solar panels. They are configured to be retractable, so when driving, you can retract them, and when charging, you can extend them to collect as much solar energy as possible. A complete description of this solar charging system is at the second half of the video. The video you're watching now is of the retracted position of the four 150-watt solar panels. They retract into polycarbonate channels and are retained by pins to maintain that position while you're driving. This video shows the solar panels in their extended state. They basically pull out from the channels and then the pins retain them in the extended state. This allows all of the surface of the 450-watt solar panels to be exposed.
All right, this is an explanation of the system. We basically have a solar charge controller, so the power comes down through the sidewall from the solar panels into the solar charger controller. That controller charges a bank of four 12-volt batteries connected, two in parallel, and then the two pairs of two in series, and then the two pair in series to parallels. We have 24 volts at 70 amp hours. That goes and actually powers a 3,000 watt pure sine wave inverter at 24 volts, which then provides the 110 out to the charger. This charger is adjustable from 10 to 16 amps at 110. Okay, that then runs under the car, comes out the grill, so you can pull it out and charge the vehicle. Now, so there's two modes. Actually, let's step back. So this box here is actually here to switch between two modes. In the front, there's a switch beside the charge ports. One of the switch in one direction is for grid charging. Switch in the other direction is for solar charging. During grid charging at the house or wherever you're going to charge at, you can flip it to grid charging. It actually uses 12 volts from the DC to DC converter built into the vehicle to go through a inverter that then goes to a 24 volt battery charger. That way you can actually get one cycle when it's charging at home. So you kind of cheat and you get one full cycle, because in addition to the car battery, it's also charging these batteries. Now, the way the charger works is the 12 volt system DC to DC converter is actually on until the charging is complete. When the charging is complete, that battery is disconnected. I had trouble to begin with because I'd come out and the battery would be dead. So I had to add this. This whole purpose is to monitor the battery voltage. Once it drops below a certain point, knowing that the DC to DC converter has turned off, it'll shut off the inverter, keeping the battery from depleting the rest of the night. So that's the purpose of that circuit. This is actually a display for the solar charge controller. So that's the basics of the system.